Now we're going to get to section 5 of chapter 4, and this is about solving logarithmic equation and exponential equations. So basically just 3 videos, one going over exponential, one going over logarithmic, and then some application ones. Okay, so we'll start with exponential ones. And so when we look at exponential equations, we have already kind of dealt with these before, so here's an example, right? We can rewrite 16 and 256 with the same base, right? Because we can rewrite 256 as the same base with 16, right? Because 256 is 16 squared, and that's raised to x minus 1. So we can solve these ones because we can rewrite the bases where they're the same, and then we just raise our powers to power, so we multiply, make sure we distribute, right? And now since the bases are the same, now the exponents have to be the same. And so this one's not true for any problem, because when I subtract here, I get -2 equals 0, and that's a contradiction, right? So that actually means that there is no x that I can plug in here that will make this statement true. So now we do it more difficult equations with exponentials where we can't turn the bases into each other, right? So I can't turn 7 and 12, I can't rewrite them with the same base. We'll come back and do the logarithms a little bit later on the next video. But here we'll just do an example of an exponential, and there's 2 ways to do it. It ends up being the same each time. One is I could turn this into a logarithmic, right? So my base would stay the base of the log. My exponent and my answer would switch places, right? Because that's what exponential and logarithms do. They're inverse one another, so they switch their x's and y's, right? And my answer is my y, so and my variable, which is x here, is my exponent. So the answer is my output, and the input is my variable on the exponent, so they switch places. So 12 goes with 7, and the answer is x. Okay, so now we learned last time the change of base formula, right? So we could use the change of base formula here. And then I just have to be careful with my calculator, right? Because when I hit that log button, it automatically pops up parentheses, so I need to make sure I close that, right? Same thing when I divide. I want to close that. Now it's okay here, but in the future, notice I only have 1 log on top, which is fine, and then I divide by 1 log, so that's okay. But in the future, if you have more than 1 log on top, you need to put your numerator in parentheses. If you have more than 1 log on bottom, you need to put that denominator in parentheses, or your calculator is going to, it's not going to do what you want it to do. It's going to do what it's supposed to do and follow an order of operations. So we can enter this into our calculator. You know, you can hit log of 12, close your parenthesis, divided by log of 7, or ln, right? And we get x is equal to 1.28 rounded, right? So that's how you solve these ones with just whenever there's a single variable, or in one of the exponents there's only 1 variable. So notice that this other number on the other side of the equal sign does not have an exponent to it. So here we can just switch to logarithmic form and solve it. If this had a variable, then I need to take the log of both sides. So I'd have to take, you know, ln or log base 10, because I can use those on my calculator. But I would have to do it of both sides, okay? And so my base is 10 here, so I don't need to write it. And then I can use my properties of exponents. That brings that out front. And I can divide by log 7. So you see I end up with the change base formula, right? These two right here are the exact same thing. But I need to do that especially if I have a variable as one exponent and another variable as another exponent. So if I'd have something like this, then I would have to make sure I do the log of both sides. Now, before you do the log of both sides, or before you switch it to exponential, your base needs to be by itself. Okay. Here's a more difficult one, but let me add one in between. Okay, so say 3e raised to the 2x plus 1 equals 12. Okay, so here we want to solve this one But we need to get this base e by itself first. So we're going to divide by 3 because it's 3 times that. So we're going to divide both sides because we need to get that base by itself. Now you could switch this to exponential, right? Because this doesn't have a variable on it, on the exponent here. So you could switch this to exponential, or you could take the log of both sides. Now either way, what type of log are you going to take because of that base e? That means you're going to take the ln, right? So you could take the ln of both sides, or you could switch to a log, a natural log. Move my exponent out front. Now when I have more than two terms here, I want to put that in parentheses. Okay. Okay, now I can divide. No, actually what's great about e is ln of e. What does that equal? Isn't that log base e of e? And that is equal to 1, right? E raised to what is e? That's 1, right? So ln of e does equal 1, so we just get 2x plus 1 equals ln of 4. And if we subtract both sides by 1, I cannot take ln of 4 and subtract 1 and get ln of 3, right? Because ln of 4 is a number, right? It is a number. It is 1.38. So it's just like this. If I had this 2x minus 1, I don't get x, right? I don't take 2 minus 1 and get x because I don't know what this number is, right? So I can't subtract them. Just like this, I don't know what this number is, so I can't subtract 1 from it. So I just have ln of 4, right, minus 1 equals 2x. Then I can divide by 2, divide by 2. So then on my calculator, this is what I type, because now I have two terms in my numerator, so I need to put my numerator in parentheses. When you click that ln button, it's going to bring up a parenthesis. Then you can type in 4, close that parenthesis, and then close your numerator after you subtract 1. And then you're going to divide by 2. So if you don't put this in parentheses here, what your calculator is going to do is it's actually going to take 4 minus 1 and get 3 and take ln of 3. But that's what I set up here you could not do, right? So we need to make sure that we close off this parenthesis right here and then close off your numerator. Okay, so we can do that. And then at the very end we divide by 3 and we get x is equal to 1 or 0.129, somewhere around there approximately. Okay, so that's kind of how you solve kind of the two basic ones. Just make sure you get that base by itself, okay? And then here's a more complicated one. This is where we have different bases, right, with exponents, variables in both the exponents. So here we definitely have to take the ln or log of both sides. Again, log and ln, they're both logs, right? So here's base 10. So I can't do log and ln. It has to be the same base. 0.4. Raise to x plus 1. Then we can use our properties of exponents that bring these down in front. And again, because I have two terms in my exponents, I want to put that in parentheses. And I would wait. Don't try to figure out what log 3 is or what log of 0.4 is. Okay, now what we need to do is we can distribute log of 3, because log of 3 is a number, right? So I can distribute a number inside parentheses. I cannot distribute log into parentheses. I can't distribute just log, the letters log, into a parenthesis, right? This is saying I'm taking the log of this, right? So I can't distribute a log. I can distribute a log of a number, because the log of a number is a number. But I don't know what just plain log is, right? So we can't just distribute log inside the parentheses, but we can distribute log of a number. So we're going to do that on both of these. Make sure you distribute to both, right? So we get 2x log 3 minus log 3 equals x log of 0.4 plus log of 0.4. Now it doesn't matter how you move these next, but we're going to move them over so my x's are on one side and my other logs are on another. So it doesn't matter how you move these. Eventually you'll get the same answer. You just might have negatives in your fraction at the end in different places than I might, but you would still get the same answer. Okay, do this one step. Now again, I cannot subtract these, right? I cannot take 2x and minus x and get an x log of, because I don't know what log I'm getting, right? So these are not like terms because I don't know what log 3 is and I don't know what log 0.4 is. So I'm just going to set them next to each other. So 2x log 3 minus x log of 0.4 equals, let's go ahead and move this over as well, right? Log 3 on both sides. Again, I cannot combine these, and I wouldn't put those on a calculator yet. Okay, so I'll just wait. So log of 0.4 plus log of 3. Now what you're going to do is we want one single x by itself. Right now we have two x's, right? An x here and an x here. So we want to get rid of that. Well, we notice we have a binomial, right? One term, two terms. So can't we factor out the GCF, which is an x? So I can take out an x, put it on the outside of the parentheses, and I get left with this. Oh, I forgot a number in here. Isn't this 3? There's a 3 right there. 3 minus log 0.4. Okay. Let's log of 3 at the end. Okay, now we're multiplying. Now we do have a single x, and it's being multiplied by these two logs, right? So to get rid of that, can't we just divide by 2 log 3 minus log 0.4 on both sides? Now here's when you put this in your calculator, you got to make sure you put parentheses around your numerator. Okay, so you're going to put parentheses around your numerator and parentheses of what you're taking the log of, right? So I got to close that one, close this one, and then close my numerator. Then I can hit it divided by, open up a new parenthesis for my denominator, close this log, and close this log, and then close your denominator. So you get x is equal to 0.0586, 0.0586, and so that's what it should be. And remember, you can always plug these back in and check them. You just might be a little bit off just because I rounded that number, right? So those are kind of the more that's the more difficult of a problem that you'll deal with exponentials. Let me go ahead and give you one more. So how about e raised to the 3x times e raised to the 2x equals e raised to the 25th. Okay. So it might seem a little complicated because there's so much stuff going on here, but remember back into when we do exponents, right? When we multiply by the same base, can't we add exponents? So we get e raised to the 5x. Now, since the bases are the same, can I just set the exponents be the same? So x is equal to 5. Right, so that seems complicated, but it's really not. We just got to think back to when we multiply by the same base, we add exponents. Okay, so then here is the homework. Start on page 446. You got 5, 13, 15, 17, and 29, and I'll go ahead and do those now. Okay, so here you go. So here we can just pretty much switch this to log, right? The base is 3, and then the x and the 7 switch places. So we're tucking the log of 7 with base 3, and it's equal to x. So now we can use change of base formula. Log 7 divided by log of 3. Make sure you put these in parentheses, and the answer is 1.771. Okay, number 13. Here we're going to have to log both sides, make sure the bases are by themselves, which they are, and they're set equal to each other. So then we can log both sides, or ln of both sides. Sometimes I write to write ln, so then I don't have to write 2 letters instead of 3. Then we can use our logarithm properties, move those out in front of the log. Since there's binomial, go ahead and put that in parentheses. Okay, then we can distribute the logs. Distribute the logs, so we get x log 6 plus log 6 equals 2x log 4 minus log 4. Now you can move these around however you want to. Just going to put my x's over here to this side. Put my numbers over here. Then I'm going to factor out an x. That should be log 6, right? This right here is actually a 6. So you got to be careful there. Divide both sides by log 6 minus 2 log of 4. Divide by, make sure you, when you do this on your calculator, make sure you put those numerators and denominators in parentheses. So number 13 is 3.24. And so that's the answer. Good thing with these odd problems, check the back of the book. Make sure you're correct, because you can easily make a calculator mistake. So that's why probably on test and quizzes you plug that number back in, see if it works out. And at least it should come close, even though you might be rounding it here. Okay, as we look at number 15, a little bit different, because this time we have an x squared, so it's a little bit different than our example because of that x squared, but that's okay, we can still solve this. So here we only have, again, one exponent, right, with the variable in it, so we can just put this into log form, or we can do the ln of both sides, and I do the ln because of that base e, right? Because now we use our properties of logs to bring that out front. Because what's great about ln of e is, what does it equal? It equals 1, right? So now, how do I get rid of a squared? I'm going to square root, right? So I'm going to square root both sides. And remember, when you square root, you always have a plus or minus. Which is fine, because if I plug that back in and check it, remember, I'm taking my x and I'm squaring it, so it's automatically going to be a positive. Okay. Now we can go ahead and put that in a calculator. The square root of ln of 100, and it is plus or minus, right? Because it's the square root. Plus or minus 2.146. All right. So that's number 15. 15, yeah, 15. 17 is next. So let's go ahead and do number 17. This one is a little bit trickier than kind of the one we did, right? But remember, when we multiply by the same base, we can go ahead and add exponents. So I'm keeping that same base, and I'm taking 2x, and I'm going to x minus 7, and I'm adding a negative 2x. Okay, so I'm adding a negative 2x. So here, let me make sure I got this equation right, because when I take 2x and I add a negative 2x, I should get 0x here. So let me make sure that I check this to make sure it is correct. So it is not correct. This is actually a 3, so that's a 3. So then we have 3x minus 2x is a 1x, so then we have x minus 7 here, so that makes better sense. Now we can go ahead and there's two different ways to do this. You could divide both sides by e, because then when I divide by the same base, I subtract my exponents, so there would be a 1 here, so I'd get x minus 7 minus 1, so that'd be x minus 8. E to the x minus 8 equals 4. And that might seem like, hey, I don't know what you're doing there, and that's okay. So another way to do it, because then this, we could just switch that to logarithm, or take the log of both sides. So here, what I want to do on this problem is I can take the ln of both sides, okay, but then I'm taking ln of a product 4 times e, and isn't that, can I separate that into two logs, ln of 4 plus the ln of e? I can bring this using the log properties, right? That's a binomial, so put it in parentheses. Okay, ln of e equals 1, right? So this is x minus 7 This is ln of 4 plus 1, so I can't add 1 and 4 and get ln of 5. I got to take the ln of 4 first and then add 1. So now I'm adding 7, so I get ln of 4, and then I'm going to add 8, and that's going to be my x. And that's, as you can see, that's what's going to happen on this one too, right? When we take ln of both sides, when I get ln of 4, and this comes out in front, ln of e is going to get canceled, so I get x minus 8 equals ln of 4, and then I add 8. Isn't that what I did just down here? So x is equal to, on number 17, 9.386. So that's number 17. The last one is definitely a lot more trickier because you have no idea kind of what it looks like. I didn't really do an example of this, but there is one in the book of it. But if you kind of look at it, you will notice that it kind of looks like we have a constant here, and then we have 3 terms and a constant. This you can't quite see, but this is kind of, you know, it's double this one. Well, that's kind of like a quadratic, right? It's a quadratic because remember when we raise powers to powers, we kind of multiply. So this is kind of like e to the x raised to the 2 minus 6ex plus 8. Right, so then we have the same kind of thing here. Okay, so we kind of see if we replace that e to the x, they do it with u all the time. And you know, it's called quadratic form. We kind of talked about this before, but just not with e to the x. So this is kind of like x squared minus 6x plus 8, right? It's a quadratic equals 0. So it looks like a quadratic, so that's why they substitute u in for ex, right? So they're going to replace this ex with u. So now it's u is being squared, and then minus 6u plus 8. Now it looks like a quadratic, right? Just remember those worksheets that you do always, like those handout worksheets about quadratics, they change the variable on you. That's all they're doing. We're just getting so used to x that we can't see anything other than x, or we're confused, but they're just switching the variable on us, okay? But we'll come back and substitute back in e to the x at the end. So we're going to solve this quadratic, right? So we can try to CAB it. So that's c, our a is 1, times 8, that's 8. Now, what times what is 8? But I get a negative 6. Well, that's a negative 2 and a negative 4, right? So I take those, and that's u minus 2 and u minus 4. And then we divide each of those by our a, which is 1, so that's really not going to change anything. So I can really take that out, and that equals 0. Then since I'm multiplying two binomials and the answer is 0, doesn't that mean one of those binomials has to equal 0, right? So we set them equals 0, so u equals 2 and u equals 4. But what does u equal? It equals e to the x, so I'm going to substitute that back in. This is a really long process, right? E to the x equals 2, and e to the x equals 4. So now we can solve this by taking the ln of both sides, right? This is going to come out in front of the log, ln of 2, so that means x equals ln of 2, and this would be x equals ln of 4. So long process, but those are our answers. That's fine leaving them like that. If I can't scroll down anymore. Here we go. So for this, x equals, we'll just go ahead and leave it as ln of 2 and ln of 4. So we can just leave it like that, so then we don't have to round, right? So that's a truer number than actually rounding something. Okay, so that's it for solving exponential equations and kind of all the different types that you might come across. I didn't do some of the examples of these harder ones, but at least you can use your book and look at those as well. All right.